Hey, welcome to a new POPX tutorial. Today we're going to build a sphere rolling along twisted bricks. We'll learn some really cool POPX tools along the way and put together a smooth, satisfying animation. Let's dive in. This piece is heavily inspired by an amazing Blender creator and educator, Ducky3D. Check out his Instagram, there's a lot of inspiration there. He's also got some great Blender tutorials, definitely worth checking out. Overview. The network breaks down into 4 parts. First, the motion chops. This is where we build our animation channels, phase for the twist, rotation on Z, and translation on X. These 3 drive the whole network. Second, the brick instancing. A POPX instancer scatters boxes along a curve. A ramp top, driven by the phase channel, creates the twisting animation. A transform modifier translates the bricks along the x-axis. And a limit pop loops that motion. Third, the sphere animation. We start with a basic sphere. A shape fall-off defines a band around its equator. A transform pop reads that fall-off and pushes the geometry inside the band inward, creating this displacement stripe. A second transform pop reads the rotation channel and rotates the sphere. Here's why the deformation matters. Without it, the sphere has no surface detail. When it rotates, the eye has nothing to follow. The stripe gives it a visual reference, and that's what makes the rotation readable. And finally, rendering. The network is simple, PBR materials driven by a substance top. A couple of post effects on top, SSAO, and a Luma blur give the final image its depth and polish. Alright, let's get started. Hey, before we dive in, I want to show you popx.tools, the official POPX website. Here you'll find a Getting Started page with some basic examples. An installation guide. Comprehensive documentation for every operator. And a changelog for each version. Everything else lives on Patreon. That's where you get POPX itself, all the releases, the tutorials, and the project files. The links for the website and Patreon are in the description. Alright, let's get into building it. Motion chops. Let's build the motion chops network. Drop in a constant chop and name it pars, short for parameters. Add 3 channels, len for length, rad for radius, and dir for direction. The dir channel will define the direction of the animation movement. Set the default values to match the example. Drop in a speed chop and set its speed parameter to 0.08. Then drop a keyboard in chop and reference it onto the speed chop's reset parameter. Connect a math chop after the speed chop and reference the direction parameter onto its multiply parameter. From that math chop, branch out into 2 more math chops. On the second math chop, write an expression on the multiply parameter. 180 divided by math.pi multiplied by length divided by radius. That gives us the rotation in degrees. On the third math chop, reference the length parameter onto its multiply parameter. That's our translation channel. Drop a merge chop and connect the speed chop, the second math chop, and the third math chop. Rename the channels to phase, RZ, and TX for phase, rotation, and translation. Cap it off with a null chop and call it animate. And that's the motion chops network. bricks instancing. Now let's build the bricks instancing network. First, split the screen, geometry viewer on one side, network on the other. This way we can see what we're building as we go. Drop a box pop. Connect a normal pop after it. We're not computing the normals, we just need the tangents for rendering. Drop a POPX instancer. Set the uniform scale to 1.65 and the Z-axis scale to 0.15. On the distribution page, set distribution type to curve. Now build the curve. Drop a line pop, set divisions to 50, and align on the x-axis. Connect a transform pop after the line. Reference the length parameter onto uniform scale and align it on the origin. Connect a null and rename it curve. Reference the curve null onto the instancer's template object. Now create the twist. Drop a ramp top, bump the resolution, and switch the format to 32-bit float RGBA. Cap it with a null and call it twist ramp. Open the curve settings on the instancer, find twist amount, and set it to -360 degrees. Reference the twist ramp onto the custom twist top parameter. Reference the phase channel from animate onto the ramp's phase. The twist now animates. Display the POPX instancer. The instances are now twisting along the curve. Now build the modifier chain. Connect a transform modifier after the instancer. Then connect a limit pop. Then connect a POPX geometry. Disable the instancer display and switch to displaying the POPX geometry instead. On the limit pop, set limit type minimum and maximum to loop. Reference the length parameter, multiplied by -0.5 for the minimum and by 0.5 for the maximum. Reference the translation channel onto the transform modifier's translate x. We see weird behavior because local space is on. Toggle it off and the instances now move along x. To understand this, drop a visualize frame and connect it to the instancer. Now toggle off render primitives on the visualize frame. You'll see each instance's local frame rotate with the twist. That's why we needed to turn local space off. And that's the bricks instancing network. Let's move on to the next one. By the way, if you don't want to build the network from scratch, you can grab the project file from Patreon, along with the project file for every tutorial I made. The link's in the description. Alright, back to building. Sphere animation. Now let's build the sphere animation. Drop a sphere pop. On the sphere, set the frequency parameter to 100. We need more geometry detail for the deformation later. Connect a normal pop after the sphere. We're computing only the tangents here, like before. Connect a shape fall-off after the normal pop. On the fall-off page, toggle on Preview Fall-Off. This shows the fall-off as a gradient over the sphere. On the Shape page, change Shape Type to Box. Set the box size, X and Z to 2.25 and Y to 0.1. To smooth the fall-off, set transition range to 0.165 and transition aligned to -0.35. Connect a transform pop after the shape fall-off. First, set the weight attribute to the fall-off attribute that the shape fall-off created. Then set uniform scale to 0.1 to push the geometry inside the band inward. After the deformation, connect a normal pop to recompute the normals from the displaced geometry. Connect a second transform pop after the normal pop. Reference the RZ channel from animate onto its rotate Z axis. Also reference the radius parameter from pars onto its uniform scale. And reference the radius, multiplied by 2, onto its translate Y axis. Now connect a geometry comp after the transform pop. On the geometry comp, set translate Y to 0.12. This lifts the sphere above the bricks so they don't overlap. The sphere now rotates with the stripe spinning around it. Now let's see why this deformation matters. Bypass the deformation transform pop and toggle off the preview fall off. The sphere spins as a plane shape. There's no surface detail, so the rotation isn't readable. Now turn it back on. With the stripe, the rotation becomes visible and readable. And that's the sphere animation. Rendering. Now for the rendering part, we're not building it from scratch. I just copied the rendering network from the example and we'll walk through what's set up and how it works. First, I'm switching the geometry viewer to a panel viewer so we can see our final render as we go. Now, a couple of quick performance tips before we walk through it. On the POPX transform modifier, go to the comment page and toggle off render primitives. We don't need it. The POPX geometry already renders for us. Also, the visualize frame we connected earlier, you can either remove it or just bypass it. We don't need it for the final. Now let's walk through the rendering setup. First, a render top, where we set the output resolution. For the materials, I'm using a substance top. The textures are free and included in the project file. From those textures, we build two PBR materials, one for the sphere and one for the bricks. Same substance textures, but the metallic and roughness values are slightly different on each. I'm referencing PBR material 1 onto the bricks geometry and PBR material 2 onto the sphere geometry. On the sphere pop, I'm also changing the texture mode to fisheye so the textures wrap cleanly around the sphere. This is why we computed tangents with the normal pops earlier. The PBR material uses those tangents to remap the textures onto the geometry. The setup is simple: a camera and 3 lights, 2 cone lights and an environment light. After the render top, we add an SSAO top. It gives us nice ambient occlusion and detailed shadows. Then a circular ramp top that fades to black at the edges, combined with a luma blur. This focuses the center and gradually blurs out toward the edges. Then a level top to play with gamma and brightness. For the background, another ramp top, a clean white to black gradient composited under the main image using the under operation. And that's it. This is our final render. Thanks for watching, and huge thanks for the support. That's what keeps POPX evolving and the community growing. Come hang out on our Discord to ask questions, share ideas, or just chat with other creators. The links to the project file and Discord are in the description. See you in the next one.